Now let's look at the UPF tab. UPF is Unified Power Format. It's a language to describe the power intentions and power strategies. UPF Canvas is a solution that can generate UPF from the power diagram. As mentioned earlier, diagram is the most intuitive way for humans to understand. UPF Canvas follows the same philosophy as Clock Canvas and Power Canvas. Just like someone who is not a power expert can easily understand the power sequence with flowchart, those who are not UPF experts and not familiar with UPF syntax can easily understand and review the power implementation by looking at the UPF diagram. What you see here is the simplest power diagram example. Every power domain should have at least one VDE and one ground. So it starts with this basic structure. If a block doesn't have any hard macros or complex power domains, only one primary power and ground is okay, like this diagram. You can simply drag and drop the predefined components in the diagram as needed. Just like the clock and power design, the panel includes all the necessary components for UPF, such as VDD, VSS, power switch, level shifter, isolation, repeater, etc. Again, from our intensive experience in mobile AP for more than 10 years, we can define it. For example, if you want to add one VDD here, you can drag and drop the VDD components in the diagram. As soon as you drop it, the canvas automatically renders the possible placement locations. You can rename it and specify as related voltage and ground. If you want to add level shifter strategy, you can also drag and drop the level shifter component. The canvas also renders the possible location. You can rename the level shifter and connect its inputs and output like this. You also can specify the cell name or type. And the rules. And by clicking Show PST here in the top panel, you can create a power state table. The PST lists all VDD and VSS rails in the current power domain as columns. You can map their voltage levels for each power scenario. In this way, designers can easily define the power strategy for each power domain. If your power domain has a hard macro, you can instantiate it in the diagram as shown here. You can model the power and ground information of the hard macros and import them into the canvas as shown in here. When you drag and drop the hard macro component and select its type, the icon is automatically updated to reflect its VDD and ground information. Then you can connect the VDD and ground. You can also directly attach the level shifter or isolation cell to the hard macros like this. Once the power diagram is done, this can be instantiated in the other power domain. The diagram shown here is a top-level UPF diagram, including 4 power blocks. When you drag and drop a power domain and select the model, the icon is automatically updated to reflect the VDD and ground information of that power domain. You can connect VDD and VSS as shown here. You can also add level shifter or isolation components in the upper hierarchy level if needed.